Welcome to video lecture on partial differential equation. In last class we learnt formation of partial differential equation and solution to partial differential equation directly. That means we can easily integrable. We made those functions which are easily integrable. Okay. Today uh, in partial differential equation we are going to solve linear equations of first order. Already you learned linear equations in ordinary differential equation, but there is a no link between ordinary differential equation and partial differential equation in the method. So first, linear partial differential equation of first order of the form capital P into small p plus q into q is equal to r. Here capital P, capital Q, capital R are functions of x comma z. And PQR already we learned in the first class itself. P is equal to dou z by dou x and Q is equal to dou z by dou y. Okay. So the equation known as Lagrange's linear partial differential equation, and solution to this equation can be written as phi of u comma v is equal to 0 or u is equal to some function of v. Phi means any function which involves the solution of both u and v. And in another way, u may be written as function of v. How we got this solution means here see the standard form. It should be in the form of p into p, that is capital P into small p, capital Q into small q is equal to r, that is dx by dp, dy by dq, dz by r. That means dx by coefficient of small p, that is capital P, dy by coefficient of small q, q, dz by that r coefficient of constant r, we can write it as 1. By solving this one, how to solve this type of equation means you can combine these three or we can integrate any two of these. That means dx by p, dy by q, both side you can integrate, that is variable separable, or dy by q, dz by r, or first one last one, or sometimes it may be possible to add all those values which makes denominator equal to 0, or multiply into x into dx, y into dy, z into gz, like that. Okay, like that. If we solve, we get the solution. Now here we have only two values, that is p and q. P is dou z by dou x, q is dou z by dou y. That means we have only two independent variables, x and y, for the dependent variable z. Now what we are doing, suppose we have n number of independent variables, x1, x2, so on xn, and the dependent variable is z. So how to solve the linear differential partial differential equation of this type? So you can write, we have in this form p1 dou z by dou x1, p2 dou z by dou x2, so on, p and dou z by dou xn is equal to r. So here dou z by dou x1 coefficient is p1, so dx1 by p, dx2 by p2, dx3 by p3, and so on, dxn by p. Here also we have to solve all these equations, then we get the solutions of u1, u2, so on, un. Okay, and writing equation of this type is called subsidiary equation. Okay, first, whenever we want to find the solution, we have to write the equation in the form of dou x by dx by something, dy by something, and dz by something. Okay, now we do only some of the problems. Solve y plus z into p plus x plus z into q is equal to x plus y. Here it is in the form of capital P into P, capital Q into Q is equal to R. Dx by capital P we have to write, that is y plus z. Dy by capital Q, x plus z. Dz by, that is R, that is x plus y. Now we have to integrate this equation. That means generally these type of equations can be solved by taking any of two of these values, that is dx by is equal to dy by, and integrating both sides we will get the answer. But here see, here dx by z term is there, dy by also z term is there. By taking these two values, we can't integrate. Either dy by x plus z, dz by x plus y also you can't integrate. Why? Because here dy, dz is there, but in the denominator we have x term, but we don't have dx here. So how to solve this type of equation means, now what I am doing, I am adding all these denominators, that is dx plus dy plus dz, that is y plus z plus x plus z plus x plus y. It becomes 2x plus 2y plus 2z. And I am taking subtraction of these two terms, that is dx by y plus z minus dy y plus z minus x minus z. That is equal to first and subtraction of the first and last one, dx minus dz y plus z minus x minus y. So here z term gets cancelled, y term gets cancelled. So the leftover terms are in the first equation as it is, first term, second term dx minus dy by minus of x minus y, z get cancelled, z that term, dx minus dz by minus of x minus z. If I integrate first these two terms, that is both side I am writing integration. See here it is in the form of dx by x, that is if you assume x plus y plus z is equal to assume t, then derivative is in the numerator. Here also if I assume x minus y is as t, then derivative is in numerator. So I am bringing 2 to this side, then ln of derivation integration dt by t is ln of t. So ln of x plus y plus z plus here 2 into ln of x minus y. Why? Because I am cross multiplying 2 to here is equal to ln of c1. Why I am taking c1 means one more constant we are going to get here. So ln of, this is ln of a plus 2 into ln of b. 2 into ln of b can be written as ln of x minus y whole square. So that is in the form of ln of a plus ln of b. It becomes ln of ab. So ln of x plus y plus z into x minus y whole square is equal to ln of c1. We know that logarithm function is 1 1. So what is the 1 1 function? Is f of x equal to f of y implies x equal to y. So this is f of x is equal to f of y. Then it becomes x plus y plus z into x minus y whole square is equal to c1. Next, you take these two terms. That means first one, second one and third one, and integrate both sides. So integrate dx minus dy by x minus 1, integrate dx minus dz by x minus z. Minus minus both sides gets cancelled, and it is also same dt by t, dt by t. If I assume x minus 1 as t, in the numerator we have dt. So ln of x minus 5, if I bring this one to the left side, ln of x minus z is equal to ln of c2. It is in the form of ln of a minus ln of b, which is equal to ln of a by b. So ln of x minus y by x minus z is equal to ln of c2. Again, it is the logarithm function both sides. So being logarithm function is 1 1, x minus y by x minus z is equal to c2, x minus y is equal to c2 into x minus z. Or you can write x minus y by x minus z. First, consider the first solution, x plus y plus z into x minus y whole square. Second one is x minus y by x minus z. So, I am writing solution as phi of x plus y plus z into x minus y whole square into x minus y by x minus z. Or sometimes you can write one solution is equal to function of another solution also. Okay. Now, we move to the next one. mz minus ny into p, nx minus lz into q is equal to ly minus mx. This is also in the standard form. So of course it is linear partial differential equation of order 1. So we will write subsidiary equation as dx by the coefficient of p is mz by minus ny. The coefficient of q is dy by nx minus lz. dz by what term I have to write? The constant term ly minus mx. Observe this equation. We can't solve by taking any two. Why? Because if I take here these two, z term is also lie. If I take second term and third term, x term lies in the denominator. So the easiest way is to cancel the terms by adding either quotient or by multiplying x, then adding all those. Okay, here L, M, N are just constant. That's it. So what I am doing first I am multiplying x to the dx, y to the dy, z to the dz, and adding all those. So x dx plus y dy plus z dz. That means x into mz minus ny plus y into nx minus lz plus z into ly minus mx. If I simplify this one, numerator is same. This is mxz minus nxy plus nxy minus lyz minus mx. All these terms gets cancelled. That is equal to 0. That means integration, this total value equal to 0. So x dx means x square by 2, y square by 2, z square by 2. That is equal. I'm taking t right side, 2 right side, it becomes to 0. So also, and one more solution we need for that purpose. Instead of I am multiplying with x, y, z, I am multiplying L, M, N respectively. So L dx plus M dy plus N dz. So L into the value, M into the value, N into value. So then also if you simplify, here the term will get 0. So Lx, if you integrate this one, L dx means Lx, M dy means My, N dz means Nz equal to 0 or some constant here. The solution 5 will be x square plus y square plus z square, comma Lx plus My plus Nz. Okay, that's all for today. Tomorrow we'll solve some more exercise problems. Okay, thank you.